Hi everyone, my name is Rodrigo Soares. I'm a master's degree student from PUC-Rio, and I'm going to present you the article entitled A Collaborative Web Computer-Aided Design Application. Here are some topics we are going to discuss. First, I'm going to do a brief introduction about the benefits of enabling cloud functionalities to CAD/CLI application, talk about some cloud service models. We will discuss the proposed architecture for the application. I will do a demonstration of the application and some use cases, and then we will discuss and do the conclusions. Most CAD/CLI applications are developed as standalone and single user applications, so there is not collaboration. If you need to collaborate with other user, you need to export the file and share the file with the other user. So by that, if the applications are not compatible, you need to convert to other extension. And in many areas, the process of decision making cannot be isolated. So collaboration adds for problem solving. So we need applications that geographic spaced users can use simultaneously and collaboration, real-time collaboration. So when we give cloud functionalities to CAD/CLI application, we have a software with more flexibility. We can work simultaneously with other people. So let's talk about some benefits of cloud approach. So enabling cloud functionalities to CAD/CLI application, we have some benefits like first, we don't need to install the software on each machine. We don't have to be updating the software and installing the updates in each machine because the user only needs to access the URL and the software is going to work in the user's browser, and software updates will be working as soon as the new version is uploaded to production. The second benefit is simplification on file sharing. Usually the project files are shared by paper or electronic means. So using a cloud-based application, users have already the same model. Third, we can employ the processing power on cloud servers. So by this, the application runs as a thin layer. So the data structure running on the browser is just a copy of the data structure running on the server. So we don't have to employ a large processing power on user's computer, so we can use the application with mobile devices like cell phones, tablets. Basically, we have three service models for cloud solutions: infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service provides processing, storage, and other computational resources and allows the user to deploy programs. On a platform as a service, the user has the capability to deploy application, but does not have the ability to manage the cloud infrastructure except for a few environment configurations. Software as a service application, the user has access to the use of the provided application and does not have access for configuration except those implemented on the application itself. Our application basically works as a software as a service application. Now we will talk about the application architecture. It basically consists on two servers. Server 1, illustrated on this figure, stores the HTML and JavaScript files. When user type the application URL, it will send a GET message of the HTTP protocol. The server 1 will respond with the solicited files, and the browser is going to interpret these files and establish a WebSocket connection with our server 2. As soon as the WebSocket connection is established, the user can start modeling and use a half-edge data structure developed on server 2 side. To enable the WebSocket connection, we use a Socket.io library. Each client has its own socket, and the library has a room system used to broadcast messages to a subset of clients. So here we have the room system illustrated. So each client has its own socket, even those that are in the same room, but the room system knows what sockets are in each room. So if a client send a message to that room, it will broadcast this message to all clients connected to that room. Now I'm going to demonstrate the application. First, I'm going to talk briefly about some use cases, but we will see them in the demonstration. So basically, we have a user, and he can insert entity, delete entity, insert attributes. Attributes here are boundary conditions, material properties. So each entity will have its own attributes that compose the model. So we can create a room, join a room to work in collaboration with other users, and we can send messages to our chat system to all users connected to the same room. So here we can have two users working simultaneously, and they share the same model on the server side. So when a user calls an action, it will handle um, on the server side, and will share the updated model back to other users and the sender as well. So now I'm going to demonstrate the application. Here we have two instances of our application running in two different browsers. So they are two separate instances. We can model in a standalone way. So here we have a model here. The half-edge data structure handles the topology and sendbacks the updated model, and the interface displays the model. Now I'm going to create a room. I will call this one instance 1. Here we have a token of this room. Here we have our chat system, and I'm going to let instance 2 join. So I'll call here instance 2, paste the token, and okay, we have the same model here. We can model here. I will snap, toggle grid, and it updates simultaneously on the other instance. We can type a message. It appears here and back. And we can continue modeling. Now I'm going to set some attributes. I will select this edge here and put our uniform load color, and select this edge here and put support conditions. If I select these and let their value as 0, we are saying that dx translation and dy translation are blocked. So here I will put the same color as the uniform load here, hit apply, and we have a simple model. So as conclusion of this work, the application has the capability of designing simultaneously and cooperatively, as well as discussing with other users through a chat system. It can be applied to educational fair applications to ease the task of teaching, as everyone will have access to the same information at the same time. We still have to do an additional work to improve its performance as well as the interface, so we can use it in mobile devices. It is also interesting to run a benchmark to assess better the application performance and to evaluate the compatibility with different browsers. Here are some references we used in this work. Hope you all like it.